The James Webb Space Telescope, JWST, is the most powerful instrument for observing the cosmos that has ever been available to mankind. It was launched into orbit around the Sun-Earth Lagrangian point L2 in late 2021. JWST was expected to be able to look further into the depths of space than any previous telescope and capture the light of the first stars and galaxies formed after the Big Bang. On July 12th, NASA released the first images from JWST, which turned out to be the deepest and clearest images in the history of space observations. JWST's predecessor, the Hubble Space Telescope, looked back 13.3 billion years and photographed cosmic objects formed 500 million years after the Big Bang. It is believed that during this time, known as the Epoch of Reionization, the first galaxies formed and gravity condensed the gas inside them into the first stars, which in turn produced the first heavy elements such as carbon and oxygen. Using the James Webb Space Telescope, astronomers hope to look even deeper into the so-called Dark Ages, the period between 380,000 and 550 million years after the Big Bang, when the universe was filled with hydrogen and helium atoms. Over time, much of the hydrogen reionized, turning into protons and electrons, allowing light to spread through space. Astronomers call this event, which occurred about 250 million years after the Big Bang, the cosmic dawn. As the universe expands, light expands to longer wavelengths beyond the visible spectrum. By the time the signal from the most distant galaxies reaches us, it is already infrared radiation. The Hubble Space Telescope detected a small fraction of it during its latest ultra-deep field IR survey. Early galaxies have also been found to be different from those closer to us in space and time, having less distinct and more compact structures. The James Webb Space Telescope makes observations exclusively in the infrared. It is equipped with special cameras that allow it to explore in visible light the inner regions of galaxies obscured by cosmic dust. Scientists hope to witness the earliest stages of star formation in newly formed galaxies. Previously, the galaxy GNZ11 in the constellation of the Big Dipper, discovered by the Hubble Space Telescope in 2016, was considered the most distant astronomical object. Its light originated 400 million years after the Big Bang and has been traveling to us for 13.4 billion years. However, the universe is constantly expanding, and the distance to GNZ 11 in light years is now much greater, about 32 billion. The top position in the table of the most distant objects in the universe has been updated several times since the data from JWST. That position is currently held by the galaxy Sears 93,316, discovered in July. It was born just 250 million years after the Big Bang. WHLO 137 LS, also known as Earendel, is currently considered the farthest star. It formed approximately 900 million years after the Big Bang, and its light reached Earth 12.9 billion years ago. The star was discovered in early 2022 by the Hubble telescope using gravitational lensing of a galaxy cluster in the constellation Cetus. On July 30th, 2022, the James Webb Space Telescope captured a clearer image of it. The parent galaxy of the star, WHL 0137ZD1, has been unofficially named the Dawn Arch because the lensing distorts its light, making it appear as a long crescent shape. According to the widely accepted cosmological theory of the Big Bang, the number of cosmic objects and the complexity of their organization should decrease as one goes further back in time and space. However, the first images from the JWST telescope showed that the density of galaxies on the outskirts of space is almost the same as what we see in our nearby surroundings. Thousands of objects emerged when the universe was very young, many of them showing complex shapes indicative of long evolution. Scientists believe this indicates that galaxies began forming much earlier, between 120 and 220 million years after the Big Bang, and that the first stars made of hydrogen and helium could have formed as early as 100 million years after. In addition, giant planets the size of Jupiter were discovered in the Orion Nebula, floating freely in space without being bound to any star. These discoveries were made possible by the JWST, launched into space in December 2021. Equipped with a 6.5-meter gold mirror and complex instruments operating at temperatures close to absolute zero, this telescope cost $10 billion. The James Webb Space Telescope has a huge mirror that allows it to observe almost the entire visible universe, but the telescope itself does not have external cameras and is located at the Lagrange point L2, far from low Earth orbit. Because of this, there is no chance that anyone will ever be able to see the entire telescope. However, the addition of a lens in the form of an obscuration to the near cam allowed for the observation of the image of the main 6.5-meter mirror reflected through the secondary mirror. NASA used this opportunity to align the mirror segments before the telescope's launch. As a result, the James Webb Telescope was able to take its own space selfie. The expected lifespan of the JWST promises to be long, with many exciting discoveries ahead. The telescope has consumed less fuel than expected for orbit maneuvering around the Sun, potentially doubling its expected lifespan to 20 years. However, over time, its functionality will gradually degrade due to meteorite impacts and cosmic radiation. Astronomers are confident that the most exciting discoveries from the JWST are yet to come, especially in the study of exoplanets. It is expected to lead to remarkable revelations about the chemical composition of their atmospheres and the discovery of many strange and unusual worlds.